morning. My name is Jim Starika. I'm a soil scientist at the Wilson Research Extension Center. I guess Clara told you all that. And I've been asked today to describe changes in soil pH that I've seen. And the data I'm going to present is all from samples that we've collected at the research center. I will be using 3 data sets. And in the interest of time, I'm just going to be mainly focusing on the changes in soil pH that occurred between the initial sampling time and the most recent sampling time of each data set. And for all 3 data sets, the most recent sampling time was this past fall. Also, all the data I'm presenting is from samples that are of just the top 6 inches of soil. So keep that in mind as you listen to this talk. Now for this presentation, I'll be using the soil pH categories that were developed by the NRCS, and specifically the data I'll be presenting falls into 7 of their categories, ranging from very strongly acid to moderately alkaline. And as just a reminder, if the soil becomes strongly acid, that's when crop yields may begin to be reduced. And if the soil enters into that very strongly acid category, that's where the yield reductions can be quite severe. The first data set I'll present is data that's been derived from soil samples collected from the seed increase fields at the research center. Now we have pretty good records of these samplings, including maps back to about 2009. Before that, the records are not as complete, so I haven't included any of that earlier data. And even so, the data set was kind of messy. What I mean by that is some year the fields are subdivided into 2 or more fields that were sampled separately. In other years, 2 or more of the fields are combined, and that combined area was sampled as a single sample. And also I found that not every field was soil sampled every year. But going through the data, I did find 7 fields that were sampled fairly consistently during this 11-year period. Now, all these fields were dry land, and the soil is predominantly loam textured. Some of these fields may have been tilled during the beginning of this time period, but since 2014, everything at the station has been no-tilled. And because these are seed increase fields, a variety of crops are grown on these 7 fields. Now, during the first year, 2009, 2 fields were in the moderately acid category, and the remaining 5 were in the slightly acid category. Now, by last fall, the level of acidity had increased in all but one of the fields. And as a result, one of the fields moved from the slightly acid category into the moderately acid category. So there really was not a big change in the soil acidity level of these fields. Also, while the general trend was an increase in soil acidity with time, the change was not consistent from year to year. Some years the acidity actually decreased. And because of the limited size of this data set, it was really difficult for me to draw any other conclusions. The second data set is from an irrigated tillage study at our Nesson Valley research site, which is located east of Williston. Because this is a research study, the sampling has been very consistent. We've sampled 36 areas, actually 36 plots every year. And these areas were consistent in size and location from year to year. The site is irrigated, and the soil there is a fine sandy loam. And during the course of this study, 1/3 of the plots have always been conventionally tilled, 1/3 have always been minimally tilled, and the remaining 1/3 have always been no-tilled. And all the plots in this study follow a corn, soybean, barley rotation, but the plots have been divided into 3 groups, with each group at a different point in the cropping rotation. so that every year each crop is grown on a third of the plots. At the start of this study in 2008, 26 of the plots, or in other words, 72% of the area, uh, was in the slightly alkaline category, and 10 plots, or 28%, was in the moderately alkaline area, category. You'll notice that this soil, or the soil at this site, is quite a bit more alkaline than the soil at our dryland site. And I think this is due to the low intensity farming that was practiced at this site prior to its purchase by the Research Center in 2004. Now, by last fall, the level of acidity had increased in all but one plot. Or maybe I should say the level of alkalinity decreased in all but one plot, since a decrease in alkalinity is the same as an increase in acidity. More specifically, the number of plots in the two alkali categories decreased, while the number of plots in the neutral category increased. Now, while this change is a beneficial change, it's better for plants or crops if the soil is neutral than it is if the soil is alkali. This change was not something that we intentionally tried to do. And if this trend continues, the soil may become acidic in the future. Now, as with the previous data set, the change was not consistent from year to year. Some years the alkalinity decreased, where other years it increased. And also the overall trend appeared to be less in the conventionally tilled plots than it was in the minimally tilled or the no-till plots. And this is probably because of, like Dave said, the greater soil mixing that occurred in the conventionally tilled plots, and this helped buffer or resist the change in pH. The third data set I'll present today is from a crop sequence study at our dryland station. Because this is also a research study, the sampling again was consistent. There was 80 plots, so we have 80 samples that were obtained from the exact same locations every year. Just a reminder, the site is non-irrigated and the soil is a loam. And this site has been entirely no-tilled for the duration of this study. And in this study, various crop sequences are grown side by side for comparison. So, and these sequences include both some short 1 or 2 year crop rotations, such as continuous durum or alternating durum fallow. And it also includes some longer term 5-year crop rotations. Now, at the start of this study in 2013, the soil ranged in classification from strongly acid, that was 11 of 80 plots or 14% of the area, to slightly alkaline, which was 3 of the 80 plots or 4% of the area. And the most populated category was the moderately acid category, of which 35 plots or 44% of the area being in that category. Now, by last fall, 7 years after the study had started, the level of acidity had increased in 71 of 80 plots, or in other words, had increased in almost 90% of the area. The moderately acid category was still the most populated category, with its count increasing by 1. The number of plots in the slightly alkali, neutral, and slightly acid categories decreased, while the number of plots in the strongly and very strongly acid categories increased. And you'll see now there are 31 plots, or 40% of the area, that's in the strongly acid or very strongly acid category. And this is of concern because, remember, this is a level where soil acidity begins to negatively affect crop yields. Also, I was a little surprised that the size of the change in acidification did not appear to differ among the crop sequences. I thought that it might vary because there have been different amounts of nitrogen fertilizer applied to the different crop sequences, but that's not what happened. So in summary, the overall trend of all 3 data sets was for the soil acidity to increase with time. However, the amount of change varied from year to year, and It was not always consistent. Some years the acidity actually decreased. But overall, the trend was overwhelmingly that there was an increase in soil acidity with time. So the acidity level in our soils is beginning to reach those critical levels where crop yields will likely be reduced. I also want to remind people that because acidification is greatest at the soil surface, problems will be detected sooner if we take shallower surface samples. Instead of collecting the traditional 6-inch soil samples, you may want to consider collecting 3-inch surface samples for pH analysis, or perhaps even the 2-inch soil samples, 2-inch surface soil samples. This concludes my presentation. I hope you find this information useful, but I also hope that you will remain aware of the potential for soil acidity problems to develop and will remain watchful. I'd like to thank you for your time.
Great, thank you, Jim. I see one question in the chat. What soil depths were these taken?
Yeah, all these samples were taken from the 0 to 6-inch depth.
Any questions from the audience here? Okay, seeing none. Any more
Oh,
online?
Claire?
Yes.
I do see there is one question in the chat. The question was, any thoughts on factors that affect pH or weather or time of year? And that's something I do want to look into more detail at. All the samples were taken about the same time of the year. They're all taken in the fall after harvest. So I don't think that's what was causing the changes I was seeing from year to year, but I do want to follow up and see if I can find something that's causing that, why some years we have a decrease, some years we have an increase.